everyone, I'm your learning buddy Samriddhi at Study Your Bit. Economics can be a bit tricky sometimes, but don't worry, I've got your back. Using certain techniques and tricks, I'll try and make economics a bit simpler for you. Population regression is based on all data points in the study. Imagine you as a student reach out to 25 college seniors and ask them their salaries based on their years of work experience. And you calculate it up to 5 years of work experience. Okay. So for 1 year of work experience, 5 people tell you their salary. For second year of work experience, again 5 people respond. For third year of work experience, another 5 people respond. So you have a total of 25 data points, and that is your entire data set. So 5 people in each of the 5 categories. The 5 categories are different years of work experience: 1, 2, 3, 4, and 5. How will you calculate your expected salary for each of these categories when the individual observations within the category only differ? For example, in this category, which is work experience of 1 year, first person is getting 20,000, the second person is getting 25,000. So within the category of 1 year of work experience, individual observations are also varying. This is a population data set because you reached out to all 25 college seniors. So that's when we use conditional mean. And conditional mean is also referred to as the expected value of y. The y is salary given that value of x. X is the years of work experience. Why is it called conditional? Because it is dependent on that particular value of x. So expected salary will be different for each of the categories of x. How do you calculate this conditional mean? You just take the average for each of the categories. So just take the sum of all of these divided by 5 and do this for all of the 5 categories. So this is my expected salary given that particular category or value of X. So for first year of work experience, I can expect about 30,000. My actual salary can be different from my expected salary, but this is the approximate that I can expect. So population data in this case is made up of 25 data points. But in reality, you will be dealing with tens and thousands and lakh of data points. But in this case, we are looking at a population data of 25 observations. When all 25 data points are individually plotted on this graph, you have salary on the y-axis and years of work experience on the x-axis, and all individual 25 data points are plotted. So your small blue triangle, they are your conditional mean, and your small black circles are all your other individual observations. So for 3 years of work experience, expected salary that you can get is 40,000 rupees. When you join all of these little blue triangles, which are your conditional mean, you get a single line, and that line is called PRL, which is your population regression line. It is the locus of all points of conditional mean. Locus is joining all of these points to make a single line. And the equation of this line, which is your population regression line, is called population regression function, or PRF in short. And because every single point on this line is denoted by the conditional mean is on the left hand side, which is expected y given that value of x. It equals to beta naught. The beta 0 is called beta naught plus beta 1x. It's called beta. X is your years of work experience, and E of y given x is your expected salary. Okay. Beta naught and beta 1 are your population regression parameters. These are also called as coefficients. Population regression coefficients or parameters. Your beta naught is also called as intercept. Intercept is that value of EY given x when your x equals to 0. So for 0 years of work experience, what is the minimum expected salary that you will get when you have no work experience? So let's say you are fresh out of college. So you have 0 years of work experience. What's the minimum or the expected salary that you can get? That is your beta naught. Okay. Beta 1 is the slope of PRL, which is your population regression line. It's the change that happens in your EY given x when x increases by 1 unit. So let's say that from 3 years of work experience, you go to 4 years of work experience. What's the change in expected salary? It goes from 40 to 45,000. So that's a change of 5,000 rupees. So as X increases by 1 year, what is the change that is happening to your expected salary? That is your slope of population regression line. I am sure a lot of you are wondering that even though the expected salary for given years of work experience is known, then why do some people get more than the expected salary and some people get less than the expected salary? Let's take this example. Let's look at 2 years of work experience. Now we know that the expected salary for 2 years of work experience is 35,000. But we also remember that in the 25 people data point, that is the population data set, somebody with the same years of work experience was making 45,000 and somebody with the same years of work experience was also making 30,000. So why is somebody getting more than expected and somebody getting lesser than expected? Well, there are multiple reasons or random and unobserved factors that can play a role on these actual salaries. One of the reasons could be education. Maybe their education background is different, or they are working at different roles in their companies, or their office location is different. All of these factors could have an impact on their actual salaries. So when there is a difference between the actual and the expected salary, we call it the error term. So error is the difference between actual income and the expected income. And this error can be positive, it can also be negative. When is it positive? It's positive in this case, which is when your actual is more than your expected, and it's negative in this case. So it's positive in this case because your actual salary is more than expected, and you're negative when your actual is lesser than expected salary. So your error term is the vertical distance between these 2 points. Now your value of U can be positive as seen in the 45 case. It can be negative as seen in the 30 case. And it can even be 0 as seen in the 35 case. So in the population data set that we saw, this 35,000 rupees of expected salary is actually somebody's salary also. So there is also somebody who is getting expected equals observed or expected equals actual in that population data set. This is very rare, but in this case it happened. In practicality, it is pretty rare, but in our example, we saw that there is a case where somebody was getting exactly what they had expected. So these are the different types of population error. And this is seen when there is a deviation of actual value from expected value. So these are the summaries of all the equations that we saw in the last two slides of population regression. You had the conditional mean, which is the expected value of y for a given value of x. In our case, it was expected salary for given years of work experience. It is beta naught plus beta 1 x. And the error is the deviation or the difference between actual and expected. So the population regression line equation or population regression function are of two types. One is of statistical type and one is of the deterministic type. And we know that when you have randomness or stochastic term in your equation, that's statistical relationship because you're also including uncertain or random factors. And this is the non-stochastic, which does not include any error or any uncertainty or randomness. And here the relationship is fixed. In practical sense, this is what is seen or is visible in reality. And this is an example of non-stochastic form of population regression function. So that's it for population regression line, population regression function, and population error. I'll see you in the next video with sample regression.